Let's talk about cryptography, the science of secret writing, with the goal of hiding the meaning of the message. And cryptography today, well, it is at the heart of today's technology. In fact, every technology that exists uses cryptography in one way or the other. So the main gist of it is to help communicate. Let's say there are two devices that wants to communicate. Unless there is this third party in the middle who, let's say, is untrustworthy. Well, and for this device, let's assume this is A, this third party is B, and then the other guy is C. So for A to communicate to C, let's assume A has to go through B. Okay, goes through B, and B sends the message to C. But since B is not trustable, well, B might want to tamper the message, right? B might want to even look at what the message is. But I want only C to know the message. So A wants only C to know what the message really is, but it has to send it through B, and B is really not trustable. So you might either look at the message or might even change the message. So what do we do? Well, one thing we can do, let's assume it has a message, let's say hello, to be sent to C. Okay, one thing we can do is we could basically encrypt it. We could, I don't know, do something else and make it look like it is completely different bits. So one thing we can do is, let's say for H, I might write A. For E, A might write, I don't know, B. For L, I don't know, C. Now, okay, based on these keys here, what A can do is it can actually change it. So H gets changed to A, E to B, okay, L to C, C, and then O. Okay, now A will be sending this exact message, okay, to B to C. So now it has encrypted the message. It's going to send it through here. So the hello has been encrypted into A, B, C, C, and O. Okay. Now the message is sent to B. Now B looks at it. Well, I have absolutely no idea what this even means, right? Now he sends the message to C. A, B, C, C, O. But the issue is, how is C gonna know? Well, what we do is beforehand we actually set up a connection to C, okay, where we lay out what is gonna be our secret key in our case. This right here. So this secret key is something I'm letting the C know about. Okay, once C knows about it, okay, we only gotta let C know only once. So once we establish a secure communication with the C, let's say, I don't know, I might send some of my individual to C and hand out these secret keys, okay, manually. And now I can send as much messages through B all the way to C. So this is something I can do. So since C has this secret key, now C is going to decode in here. So now A will be H, B will be E, L, L, and O. This is one way C can decode the message and be able to really read what A sent to C. Now this is the gist of cryptography, and now to talk about some of the terminologies. Well, the message that we are sending, the message in our case is hello, right? That A is sending. Well, this is called the plain text. Plain text. Okay, and now I used these keys to transform the message into ABCCO. Now this becomes a ciphertext. Okay, ciphertext. Now why ciphertext? Well, there's some history of this. This individual, okay, this is the name of a person, is Caesar Cipher. He was one of the first individual in order to use this cryptic form of messaging. Okay, that's why we call this the ciphertext. Now once he receives this message, he has to convert it in order to read it into plain text, right? First of all, A converts it to the ciphertext. Now this ciphertext conversion process is called encryption. Okay, A encrypts the message with these keys, based on these keys. Now C, once he receives the message, well, has to convert it to the exact plain text to make it readable. Okay, now conversion of the message from ciphertext to the plain text is something we call as decryption. And these are some of the basic terminology of cryptography. Now let's talk about different areas within cryptography. Okay, on top of it we have cryptology. Now inside of this, okay, the cryptology is broken down into two parts. One is this cryptography, the art of maintaining secrecy, and the other one is cryptanalysis. Okay, cryptanalysis. As the name suggests, it deals with analyzing different cryptographic algorithms. Now we'll learn about different cryptographic algorithms later on, and this field of study analyzes different algorithms and looks at how good they are, tries to find the holes in them, tries to break them. Now some might even see this as a process of hacking the cryptographic algorithms, but it is perfectly legal. So the researchers, cryptographic researchers, they perform analysis on the cryptographic algorithms in order to find the loopholes in them, in order to find the holes in them, and then try to make them as better as possible, try to make them unbreakable, basically. Okay, these are the two main branches within cryptology. Now inside cryptography we have different forms of cryptographies. So the first one is something called symmetric cryptography. Okay, the other one we have is asymmetric, and then the third one we call as protocols. So in case of the symmetric cryptography, there are two parties involved where we share the same exact secret key. Okay, just like the one we talked about in the above example, where there is this same exact secret key the sender uses to encrypt and the receiver uses the same key to decrypt the text. Okay, this is called a symmetric cryptography, where the sender and the receiver have the common key, okay, that they use in order to encrypt as well as decrypt this exact same key. So if the sender and receiver know what this key is, well, they will be able to basically apply the key in order to encrypt and decrypt the message. This is the symmetric cryptography. Okay, whereas in the case of the asymmetric, we have multiple keys. So we have different keys. So different keys for encryption and decryption. So we have one key to encrypt the data and then another one to decrypt the data, and this is also called as a public key cryptography. Okay, public key cryptography. And the reason it's called public key is because there are two types of keys. So the first key we call as a secret key, or it's also called private key. Okay, and then the other key we call as a public key. Unlike the symmetric, where both the sender and the receiver use the exact same key and the key is visible to both of them, but here the secret key is only visible to the sender. Okay, the sender has the secret key, and now the receiver is going to receive the message sent by the sender through this public key. Okay, this is the idea of the asymmetric cryptography, where there are two keys, two different keys, one key for the encryption, the other key for the decryption. Now cryptographic protocols, these deal with the application of these cryptographic algorithms in a real world setting. For instance, you might use these cryptographic algorithms alongside some transmission protocols in order to make the real world use of it, maybe to send the message about the internet. Now this in a nutshell is a high level view of the entire field of cryptology, and over the next videos we'll be talking about this cryptography. So we will spend most of the time just learning about the field of cryptography. We'll learn about different cryptographic algorithms, the symmetric as well as the asymmetric, and we'll also briefly talk about protocols and how they work.